Linear systems. We already know what linear means. What does it mean? Repeated change to what? The x and y axis. It does not have to be the same change, but it has to be repeated change. Resulting in what kind of pattern when we graph it? A straight line. Yes? Okay. What then is a system? Forget about math. What does it mean in English? If I have a system for doing something, what does it mean? Something you do every single time? Okay. Anybody wish to add to that? Okay. I would hazard that you could add that not only is the system something you do every single time, but it is something that has multiple steps. I do this, then I do this, then I do this. So in math, a system is a comparison. I got blue. Oops, that's not a companion. A comparison between two or more equations. Okay? Those equations may, please underline may, share a solution. Now, what are the two ways in math class we illustrate the solution to an equation? I will remind you of one. What are the two ways you could illustrate the solution to that equation? You could graph it. And you could do it algebraically. What would it look like algebraically? First of all, how many solutions are there to that equation? No. Those are the four different ways we could write it. Infinite. There are infinite combinations to that equation that would work, right? How would we write one of them algebraically? Kobe. Pardon? That would get me the slope. But slope is not coordinates. I just gave it away. Damn. Noah.
Coordinates.
Coordinates, right? So, could I have this as an answer? Is that okay? So that's an algebraic solution to this equation, yes? How did I know I could put 1 in there? Noah?
You fill in the 1.
I fill in the 1, but why am I allowed to put 1 in automatically?
You can fill the y equals 8.
You're absolutely right. I can fill the x. But why? Why is it that, pardon me?
Because it's multi-linear by 1.
Okay, so you're telling me what I am doing as well, just like Noah is. Why can I put 1 in? Why couldn't I have started with 8? Could I have started with 8? Yeah, and then I would have had to work backwards. But why did I start with 1? Why did I start with the x?
Because on a graph axis.
Getting warmer. Not quite. X is the input, guys. We know this. It's the independent variable, right? You do have a y-intercept, yes. But if we were going algebraically and you were making a table of values, you would start with the x's because they are the independent variable. Y results in what we do to x. Okay? That's algebra. On a graph, now all that other stuff you were saying. Start with the y-intercept, do the slope that Kobe says, all that stuff. And what does that graph then give me? The infinite illustration of every point that will work. Right? So you guys are aware that this equation, which you know graphs a line, has an infinite amount of solutions that you can write algebraically and graphically, right? And that's what we can do. That's what we've been doing the last few units. Okay? So now, we got to remind ourselves what these things are. Now, Gerard has already told us that a linear equation is a linear equation, okay, not a line. A linear equation is what? How would you guys define that? Nobody can define a linear equation. Supreet. Both sides are equal. Oh, I see what you're saying. Okay, when the left side equals the right side. Yes, okay, good, excellent. Anybody else? You all know what a linear equation looks like. You can all give me examples of it. You can all work with it, but none of you can tell me what it is. Alon. Does it have to be X and Y? Has to have... Does it have to have an X or a Y? Does it have to be X or Y?
Variable.
Has to have a variable. What kind of variable? Supreet. Yes, it has to have an independent and a dependent variable. If it doesn't have that, you're not going to be able to graph it, right? Okay, so a linear equation is it should be an equation in at least one variable, right? Because it's got to have at least one variable, right? And I'm going to mix two definitions together, whose graphed points create a repeated pattern. Okay, so I'm borrowing from graphing and algebra now. So, you guys are smart kids. The linear equation makes a line with a repeated pattern that's predictable, and a linear system compares two or more equations, or a system compares two or more equations, then what must a linear system be? A system compares two or more equations. A linear equation is this special kind of equation. What must a linear system be, Noah?
One that compares two or more linear equations.
Yeah, excellent. A linear system is I want to change color again. Is a comparison between, not between two or more linear equations. And what are the ways I can compare them? Either algebraically or graphically. Okay? So what do you think the solution to a linear equation is? Or, a lie. A linear equation has infinite solutions, yes? And if I have a second linear equation, it too will have infinite solutions, will it not? So if I then compare those two linear equations in a linear system, what must happen for that linear system to have a solution? You really have to think about that. On a graph, where do the solutions to a line lie? The points on what?
X and Y.
X and Y on what?
To the left.
Raining cats and dogs. How many x's or y's have I drawn?
Infinite.
An infinite amount. Right?
Yep.
Okay. Is that a linear equation?
Yes.
No, that's a line.
Oh, really?
It represents a linear equation,
Yes.
right? Where do the solutions to that linear equation lie?
Infinite.
On the line. Okay? That's a coordinate. Is that a solution to the equation? That's a coordinate. Is that a solution to the equation? That's a coordinate. Is that a solution to the equation? Yes, excellent. So this line is making up infinite solutions. Is this a system yet? Why not? Because it's not comparing two. Yes? Everybody okay? All right, so now there's another line. Where do its solutions lie?
On the line.
On that line. So that's a solution to the second line, yeah?
Yeah.
My colors are gone here. It's a bit of a pain. Right? Is that a solution to the second line? Is that a solution to the first line? No. Why? It's not on that line. So where then is the solution to the entire system?
Where they cross.
Where they cross. Because that point exists on both lines. Everybody cool? So let's go back to our notes. To solve a linear system, what does that mean, do you think? I've become British. Do you think? Well, that's a comparison, yeah? I just got to go to the loo.
Coffee. Saying coffee.
I'll knock you up in the morning. I won't really. I'm just going to knock on the door so you wake up. That's what it means. But in Britain, if you're knocked up in the morning, you are not getting pregnant. Don't worry. It is true. Some of you must be British or have British heritage in your life. You've heard the phrase, I will knock you up in the morning. You arrive in Britain and they say, I'll knock you up in the morning. You're like, wow, this is a full-service hotel. That's good comedy, guys. I know it's first block, but I gave you 10 minutes to warm up before I got here. That's good comedy. So what does it mean to solve a linear equation? I mean a linear system?
Finding the point.
Intercept.
Finding the points. So finding the coordinates that do what?
That intersect both lines.
That only works if we've got the line, because we can also do this algebraically. Find the coordinates which satisfy. Well, you're going to get knocked up in the morning, so. Finding the coordinates which satisfy all of the equations in your system. Okay? Everybody cool? All right. Now, to do this unit, you're going to learn 3 ways to solve these. We're going to start with graphing because it's the easiest. Graphing is done by seeking the intersection of 2 or more lines. So this is pictorial. You're going to draw it. These two are both algebraic. So no picture. Okay? This one is the one that is used more in, or these two are used in reality. Because of course, if we're graphing, it's going to work out to a perfect number, yeah? whereas in reality it almost never does. Okay? So we're going to start with graphing, because that's what we're good at. So first thing, step one, we change an equation to our good friend slope-intercept form. Do we have to?
No.
No. We can use all the other forms, but slope-intercept is the easiest one to graph, right?
Yeah.
So, what does slope represent? No. M is what represents slope. What does slope represent?
Rise over run.
Okay, the slope represents, rise over run is how we find it on the graph, but what does it represent? Hannah, you said it, I think.
Steepness.
Change. Yeah. The slope represents the change in the dV divided by the change in the IV. Now in our case, that is of course x, change in y over change in x. In math class, it's always y and x, yes? In physics, it's not going to be y and x every time, is it? It'll be distance and time. In biology, it's not going to be distance and time. It's going to be bacteria and time, right? In chemistry, it's going to be atoms and time, right? As something decays. Everybody cool? But in math, it's x and y. And we use the x and y because that's the basic skill you need to go on to the other disciplines. Yeah? Because even in social studies, you will do rate of change stuff, right? Population of the world, right? Millions of people over a course of time. Sociology, psychology, everything uses this. And everything else makes fun of math. Oh, math, real life, whatever, math stupid. There's a certain physics teacher that used to work in our building that was always down on math without recognizing that without this math that doesn't really apply to anything, you can't do other disciplines. So it is still important. And what does B represent?
Variance.
No. The y-intercept. So that's just a reminder. Now, let's graph these things. So the first thing you do is change it. The second thing is you graph it. Now, I have made an egregious error in printing, and I haven't given you the Cartesian plane on your graph here. Sorry about that, ladies and gentlemen. Please forgive me and draw one on. Solve these by graphing. Now, again, do I have to go into slope-intercept form? No, it's just often helpful. Like for this one, I wouldn't bother going into slope-intercept form, right? Because it's 4, 0, and 0, 4. Correct? Right? So for this guy, which I'm going to graph with a red line, I know that 4, 0, and 0, 4 will work perfectly, right? 4 plus 0 is 4, 0 plus 4 is 4, right? So I can go over to my graph, 1, 2, 3, 4, 1, 2, 3, 4, and I can graph it. Does everyone agree? And I trust everyone is able to graph that guy that easily. Yeah? Okay. Now, the other one, which I will graph with a blue line, doesn't graph that easily, does it? No. So this guy we are going to convert. What would move? The x. So 2y equals positive x plus 2. Then what? Divide by 2. So y equals 1/2 x plus 1. Now I can graph that in my sleep. Go up to 1, up 1, run 2, and there's the point. And I graph it with a blue line. Now, what do I see? what do I see right there? I see an intersection, yes? Now, what do I know about that intersection? First of all, what is its address? 2, 2. So this is 2, 2. What do I know about that notation in a math class? 2, 2 is what? That is x, y is 2, 2. If that's a 2 and that's an x, where can I put that? In which equation? In any equation in the system. So, do I see x's all over the place? I do. I have this x, 2, plus, and I have this x, negative 2, plus. What are my y options?
1.
Negative 2. I also have y as 2, and I have 2 times 2 equals 2. Is 2 plus 2 4?
Yes.
Yes. Is negative 2 plus 4 positive 2? Yes. So does this work in both equations? Yes. So this is our solution to the system. Everybody good? Does everybody understand? Can you do this in your head? You can. You would need some practice because I've seen what happens when you guys try to do stuff in your head quickly. But this is just checking, yeah? I mean, you can see 2 and 2 works, but you better check. Everybody cool? All right, turn the page over. Put your, whatchamacallit, your axes on there. Solve by graphing and check. I'm going to use red and blue again. Are those easily graphable? No, so we got to move them around, yeah? So let's move the red one first. Who would like to start? You can move the y? That's cool. 3x equals 12 plus 2y. Now what?
Minus the 12.
Move the 12. 3x minus 12 equals 2y. Now what?
Divide by 2.
So 3 halves x minus 6 equals y. Can we graph that in our sleep? Make it so. Where do I go? Negative 6 on the y-axis. 1, 2, 3, 4, 5, 6. And then what?
Rise up 3.
Up 3, right 2. Up 3, right 2. Up 3, right 2. Cool? Then I would put my line in. I'm going to go freehand. Not bad. Good enough to trust me with doing surgery? What if you were dying?
No.
Really? You guys wouldn't let me cut you? If you were dying? Like if you were trapped on a desert island, you had an attack of appendicitis, you wouldn't let me cut out your appendix with the hand that steady?
Yeah.
That hurts, man.
I did it myself.
Thanks. You would do it yourself.
Yeah. Yes.
North American teenager, you say you've got the backbone to cut out your own appendix?
I'll find it first and then do it.
You will find it. What, the backbone or the appendix?
Both.
Okay. And the blue one. I'll work that guy over here. 2x plus y equals 1. What's the only one that's got to move?
X.
Just the x, negative 2x plus 1. So I go up to plus 1, negative 2, down 2 over 1, down 2 over, oh my good gravy. Hits right there. And again, freehand. Not quite as good. That appendix isn't looking too solid. What's the answer?
Two, three.
2, negative 3. That 2 is a what?
Positive.
An x. That negative 3 is a what? Let's check. What's 2 times 2? What's 4 plus negative 3? 1. So does it work in that equation?
Yes.
Yeah, sure, you betcha. Now come over here. What's 3 times 2?
6.
6. Uh-oh. And what's negative 2 times negative 3? Positive 6. So is 6 plus 6 12?
Yes.
Yeah, sure, you betcha. Does it work in that equation? So do we have our solution correct? Yeah. See how easy it is?
Yeah.
Yeah.
What's this? What's number 3?
Oh, wow. Number 3's got something funky in it.
It's a box. It's a line.
Boxing.
Don't worry, I will explain what it means.
I said it's boxing.
Has anybody seen that notation before?
It's like
It's like a
brackets,
fancy
but
way of writing something.
it's like 1 x.
It is similar to brackets, yes. This notation, very quickly, and this is more to show you that it doesn't always have to be a line. This notation is what we call absolute value. Absolute value is a magnitude. What's a magnitude? I was going to say it's not the guy from Community. Good reference, though. Oh, you guys, it was only 3 units ago that we were speaking of magnitude. And you've done it in science, yes. Magnitude, nothing. Supreet? It's a measurement. Oh, yes, it absolutely is. But so is a vector. There you go. It's a measurement without a direction, right? In math class, how many directions are there?
No. 360.
One, yeah.
No. I will.
4.
4.
Down
No.
straight?
Yeah.
Down left right?
Come back to me later.
Negative positive 2?
Oh!
2?
2.
Negative positive.
Negative and positive. Right? That's the only directions in math, aren't they? Now, negative and positive are right and left or up and down, correct? Okay. So absolute value is only a measure of magnitude. So direction doesn't matter. Okay? So for you guys, which way is negative? Left, that way, correct? 1, 2. As a vector, what would you say my coordinates are right now? Negative 2, because I moved 2 spaces left. Agreed? What is it as a magnitude? 2. Everybody cool? So magnitude is my distance from my starting point. Everybody good? So if I go back here and then I go 1, 2 that way, what's my magnitude?
2.
2. It's the exact same. Agreed?
Yeah.
Okay, so there's no positives or negatives. That's what that means. Because it is the value that I have traveled, not a direction. Everybody cool? So essentially what that means, and you're going to learn a lot about this next year. I'm just going to show, this is for demonstrative purposes. For your argument right now, to just show you how this works, It means there is no negatives. So if I draw the number line, there is 0. That point right there is what?
2.
2. And that point right there is what? Negative 2 on the number line.
Oh.
But in absolute value, they are both what? 2. Because they are 2 steps from 0. Is everybody cool with that? Okay. So now that you know that, how do you think you would graph this? Do you start with x's or y's when you graph? And I'm going to graph that in red. You start with x's, yeah? And when we do a graph, we always like to have some negatives and some positives, yeah? Okay. So when x is, let's go with negative 3, 0, and positive 3, yeah? Everybody agree? So, if I put negative 3 in those brackets, how far is negative 3 from 0? 3. So what would my y value be? 3. How far is 0 from 0? 0. And how far is 3 from 0? 3. Can you graph that? Well, there's a point at 0, 0. Yeah? There's a point at 1, 2, 3, 1, 2, 3. Yeah? And there's a point at negative 1, 2, 3, 1, 2, 3. Now, how would we graph it? You got to think about this. Can I input anything in for x? Yes. So I've got to connect the lines. And what would that line look like? What? Yes, it's a V. Because right there, 4, 4, yeah? But out here, when x is negative 4, the y value is still positive 4. Everybody cool? Does everybody understand how that works? Now again, you're going to see a lot of that next year, but I'm using it for, as I say, demonstrative purposes. So does everybody understand how we graph that, basically? Now next year you're going to move that V all over the place. It's not going to center right there. But I'm going somewhere with this. Everybody cool? Yeah? Okay. So in blue now, graph this guy. Do I have to do anything to him? No, I don't. We can just graph him as is, yeah? So let's do so. Plus 3, 1, 2, 3. And what's my slope? Up 1 over 2, up 1 over 2, up 1 over 2. Oh, and I hit right there. Right? Everyone agree? Except what happens when I go the other way? What happened right here? I hit again. So what does that mean for a system? How many solutions does this guy have? 2. How do you know? Because it's got 2 intersections. Does everybody understand? Anytime 2 lines cross on a graph, you have a solution. Do they have to be straight lines? In a linear system, yes. But we have graphed curves in this class, haven't we? What do you think happens when 2 curves cross? It's just another solution. It's another x and y that will work in both. So what are my 2 that work here? What's this guy? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 6, 6. And what's this guy? Negative 2, 2. Now, is 6 steps from 0? Yes? Is negative 2 steps from 0? So it works in the first one, correct? Right? is half of 6 plus 3, 6. Half of 6 is what? 3 plus 3 is what? So it works there. Is half of negative 2, which is what? Half of negative 2 is negative 1 plus 3, 2. So does it work over here?
Yeah.
So have we found our solution? Does everybody understand? Remember, the absolute value thing is not part of grade 10. But what is part of grade 10 is understanding that any time you get across, you have a solution. Is everyone cool with that? Everyone agrees? As long as there is a cross, you have a solution. Okay? Everybody cool? All right. So that's it.
We're done.
You are done. Please check out, and please notice how small the amount of questions are. That is done on purpose, because what do you have tomorrow?
We have a test.
A test. So make sure you're ready for it.
Okay.
Do you want to study your homework?
Okay?
We already studied.
We did already study. We did get homework tomorrow, I think, so if we just studied tonight.
Well, good.
Now, what I did not do yesterday, ladies and germs,